Let's learn a formula for approximating square roots when they're irrational. When you have a square root of a number, if it's a perfect square like 100, then you get a rational answer. Same thing here. But square root of 10 is different. It isn't a perfect square, and so the square root of it is an irrational number. There's a formula that will give us a rational number that is approximately equal to square root of 10. X is the number that we're trying to take the square root of, and you picture it on the number line. Before x, there's some number that is a perfect square, and after x, there's some other number that is also a perfect square, and x is between these two perfect squares. We're going to use those two numbers. The first thing you do is take the square root of the first perfect square and keep that for later. You're also going to subtract your number and the first perfect square, and then you'll subtract the larger perfect square minus the smaller perfect square. Take those three pieces and put them together in the formula. Let's try it. So here's the formula, and here are two irrational square roots. 107 is between two perfect squares, 100 on this side and 121 out here somewhere. So 107 is between them, but it doesn't have a rational square root. So we're going to use these numbers in our formula. First, we do square root of 100, which is 10, plus, and then we do some subtracting. 107 minus 100, and in the denominator, we subtract the two perfect squares. So this is 10 and 7/21, which can be reduced to 10 and 1/3. It's approximately equal to the square root of 107. Let's try square root of 45. It's not a perfect square. We've got a perfect square at 36 and another one at 49, which is pretty close. So we're going to use those three numbers. Square root of the smaller perfect square is 6 plus our two differences. Subtract these for the numerator and these for the denominator, and we get a rational number that is close to the square root of 45. Let's see how close it is. So 6 and 9/13, if you work it out on a calculator, you get something like 6.6923 square root of 45. If you do that on a calculator, you get 6.7082, and it's irrational, so it's never going to terminate or repeat. Those are pretty close in value, and that's how that technique works. Here's a couple things to think about. It really helps to memorize a lot of perfect squares. Okay, here's perfect squares from 0 to 400. Those are pretty easy to memorize. And then beyond that, if you just keep in mind these perfect squares, those can provide anchors so that you know that something like this is between 30 squared and 40 squared. So it's going to be 30 something squared. The best way to learn this technique is to pick a few random numbers and take the square root of them, approximate them using this formula. So go do some.